All right, let's talk UDP scans. So a UDP scan is a type of network scan that can be used to discover which UDP ports are open on a target machine. Now UDP stands for User Datagram Protocol. And alongside TCP, which is Transmission Control Protocol, it is one of the core protocols of the Internet Protocol Suite. It's one of the core protocols of the IP suite. The easiest way to understand the IP suite, the Internet Protocol Suite, is that it's just the collection of protocols that make the internet work. You might also sometimes hear the IP suite called like the TCP/IP IP model. Sometimes they're kind of referring to the same things. Depending on who you're talking to, they may be referring to the same thing. And it defines how data is sent, received, and routed over networks. Anyway, my point is this. That TCP and UDP are the two main transportation layer level protocols in the IP suite. They define how data moves between devices. However, they work differently. In computer terms, TCP establishes a connection between two computers first, right? And this is going to ensure that data delivery is reliable. It's going to confirm the data is delivered in the correct order and that it arrives correctly. UDP, on the other hand, is kind of like its slightly more irresponsible twin. It's going to send data, but it's going to send it without creating a connection. And there is no guarantee that the data is going to arrive. There is no checking for errors. There is no checking for order. There is no retrying if it didn't arrive because we didn't check if it arrived, right? Now, this may sound chaotic, but it is very, very useful. UDP is very useful, especially for things where speed sensitivity is an issue. Things like streaming video, right? If you're sending me videos one frame at a time, if you accidentally drop one frame, I don't want you to resend it because now I have a random frame in the middle of the video, but that frame came from 5 seconds ago, and it would just be so confusing. For a video, I would rather you just send it to me quickly, and if you drop one frame here and there, doesn't really matter. Likelihood is I won't even notice as the watcher. Same thing with like online gaming. It's all right to drop a frame here and there as long as it's fast. So just keep throwing those frames at me. UDP is useful for that. TCP, on the other hand, would make it really, really slow because it would have to like delay so that we could go find which one did I drop and then go find it and bring it back to me. And that would be just so incredibly annoying. Now, remember that I said that UDP is connectionless? Well, what that means is it doesn't establish a formal connection before it starts sending data. It's just kind of throwing it at us. TCP, on the other hand, is going to like do a, hey, I would like to talk to you. I acknowledge your response, the three-way handshake. TCP is going to do all of that to establish a connection. UDP is not going to do that. And oddly, this is going to make TCP scanning slower but more ambiguous. So to be clear, a UDP scan is a type of network scan that's used to discover specifically open UDP ports. So it's possible for me to have, there are two types of ports that you can have. You can have a UDP port or you can have a TCP port. A UDP scan is specifically looking for UDP ports, open UDP ports. So we are trying to find UDP-based services. So this is stuff that uses UDP. like DNS or FTP. All of those things rely on UDP, right? So we're looking for UDP-based services that are running on the machine, so that way the attacker, or in our case, hopefully, security tester, can identify vulnerabilities and determine what the attack surface is, and maybe locate any potential entry points or misconfigurations. So here's how it works. The scanner is going to send a UDP packet to a target port. So let's say in this case, we're choosing to send it over to port 53. And then the scanner is going to wait for a response. The first response you could get is no response at all, okay? This means that the port, this could mean a few things. This is why I said that UDP scans can be ambiguous, because a no response could mean that the port is open but the service didn't reply, or the port is filtered by a firewall. Now, if the port was closed, you would get a ICMP port unreachable message. This friend, the ICMP error. And that means that the port is closed. Or you could get a UDP reply, maybe a DNS response, since we are targeting port 53. You could get a UDP reply, and that would mean that the port is open and the service is running. Now, it might seem that like a UDP scan should be faster, since UDP itself is fast, but ironically, UDP scans are often slower than TCP. Even though TCP has to go through the whole process of establishing a connection, UDP scans are often slower, okay? And they're slower because since UDP doesn't have the handshake, what's going to happen is that a UDP packet is sent, and if the port is open, the application may respond or it may not, right? And if the port is closed, you might receive like a ICMP port unreachable error, right? But the thing is, this is kind of a disadvantage, because when you are scanning with TCP, the operating system is going to help you figure out what the port's status is, because TCP is like designed to establish those connections in a very predictable way, right? I know exactly what each response that I get means, right? So the scanner is always going to know if the port is open, closed, or filtered, purely based on the type of response or lack of response that it gets from a TCP scan. But because UDP doesn't have that handshake, there are no guarantees, right? Because UDP didn't check in before sending the data, it's just firing off a packet. There is no guarantee at what response I'm going to get back. So let's go back and look at our port 53 example again. If I send something over to, say, port 53, if it's open and the service replies, great. But if it's closed, I get an ICP error, then I know it's unreachable, the port is closed, good. But what if there's no response? And there might be no response. If there's no response, there are a whole bunch of different things that could have happened. It could be that it's open, but the service just doesn't respond to that kind of probe. Or it could be that it was filtered by a firewall, or it could be that the packet was just silently dropped. And the outcome is, because there is no response, it's hard for us to make a definitive conclusion, right? So that ambiguity makes UDP scanners slower and trickier. The other thing that makes it slower is that routers and hosts may limit how many ICMP errors they send in a short amount of time. So for instance, they may say, hey, we only send 1 per second. Okay, so if you're scanning 1,000 ports, you could be stuck waiting for hundreds of seconds just to figure out what's closed. Also, the timeouts are longer since no response could mean a bunch of different things. Scanners like Nmap have to wait a longer time before they assume a port is open or filtered, right? Because no response means a lot of things. Let me say that again. Because no response means a whole lot of things, or it could mean a whole lot of things. Nmap and other similar scanners, they have to wait before making assumptions about a port being open or filtered, right? And this is going to increase your scan time dramatically. It potentially could. And the other thing is that firewalls often block UDP packets without ever sending an error message, which could create a false assumption that the port is open. Now, despite all of this, despite the fact that UDP scanning is often slower and more ambiguous, attackers still target UDP because for several key reasons, right? And for that reason, as a defender, you still have to remain vigilant with UDP, same way you would with TCP. So, for instance, one reason you have to remain vigilant is because UDP services are often more vulnerable and or just more often like they're often easier to misconfigure, or they're more common to find misconfigured. So a lot of common UDP-based services are lightweight and simple, which makes them really easy to, number one, forget about, and number two, misconfigure. So for instance, DNS is a big one, okay? If someone can find a vulnerability in this, it's really, attackers can do a DDoS amplification or SNMP. That friend is on port 161. And if this one is often left with like default, like public or community strings in it, which can expose like internal info. So we really have to be vigilant about UDP-based services. Also, the thing about UDP-based services is that these services don't often log traffic or require authentication, which makes them really quiet targets. So they can be targeted and you might never know about it without some other kind of logging, because often they're not logging themselves. The other thing, especially concerning DNS, is DNS exfiltration. This is a real threat. It's one of the most stealthy and effective techniques that attackers use to extract data from a network. So the way it works is that an attacker will set up a malicious DNS server that they control, essentially. So UDP, very important. Now, UDP is what we call a stateless protocol. What that means is that services may not always respond like we talked about. They may not always respond unless they receive the exact right type of request. So to solve this, Nmap had to get like pretty intelligent, and it sends service-specific probes to known ports. Okay, so if we know, if Nmap knows that you are sending something to port 53, Nmap is going to not just send any old probe, it's going to send specifically a DNS query. Okay, or maybe let's say you are trying to look into port 161 SNMP. Well, Nmap is going to specifically send a SNMP GET request. Okay, and this way, if the service responds properly, then Nmap knows that the port is open, and it can identify the service version 2. You can also identify that version of the service too. Now, since UDP scanning doesn't have TCP handshaking, Nmap uses its own set of rules to guess port state based on the reply. So for instance, let's say we get some kind of valid response, some kind of valid UDP reply. Well, it's valid. Nmap is going to take that as open. It's going to say the port is open. So if you get, for instance, a DNS response back, Nmap is going to go, this port is open. But let's say you get an ICMP port unreachable, right? That type 3, code 3. Nmap is going to consider this friend to be closed. The port is closed. If it doesn't get any response at all, it's going to say, well, open, but like kind of with a question mark. We're not really too sure about that, okay? Because no response could mean it's open, or maybe it's filtered. So Nmap is going to err on the side of caution and label it specifically open/filtered, okay? Or you might also get an ICMP destination unreachable, blah, blah. And that means it's filtered. Typically some kind of like firewall is preventing you from moving on there. So if you're going to be using a UDP scan, in Nmap, we're going to use the -su flag to tell Nmap, hey, I want to scan this using UDP instead of the default, which is TCP. So I would say Nmap uppercase U and tell it maybe the ports I want to scan 53. Okay. So what this is doing is it's saying, hey, Nmap, perform a UDP scan and scan only the following ports. Only scan port 53, port 161, and port 123. And then I give it the target IP address afterwards. And of course, you can always scan all of the UDP ports. Remember, there are 2 to the power of 16 of those, like 65,000 UDP ports. You can always just do that with a -p like this, like that. But this is going to be very slow because of those long timeouts we talked about and those rate limits. So only do it if you have a lot of time on your hands. Now, of course, Nmap supports scanning with UDP and TCP separately, but you could also scan with TCP and UDP at the same time, which can be very effective depending on what you're doing. So let me give you an example of that. Let's take a look at this command. So we're saying, hey, Nmap, I want you to do a synchronized a SYN, a synchronized scan. What kind of scan is that? Is that TCP or UDP? That is a TCP scan. So we're saying, hey, do this synchronized scan for me real quick. Do a UDP scan, S uppercase U, okay? And I want you to do it on the following ports: TCP, T, port 22, port 80, and port 443, and the UDP ports 53 and 161. Now this is faster because it's going to give you, this is both faster and it's going to give you a more complete picture of which services are exposed without you having to do TCP first and UDP first. You can just get them all done at the same time.